Now, I'm going to explain some stuff about Saturn that scientists are kind of confused about, like the hexagon storm at the top, at the North Pole, and basically like a hurricane at the South Pole, the rings, stuff like that. Now, I'm going to use a fidget spinner and kind of give an example here of its rotation and wobble. Now, let's see if I can balance this right. All right, now watch when I do this. See how it wobbles? And imagine me doing that is the rotation around the sun. Now it's spinning so fast that when it's going around the sun like that, it's got a wobble to it. Okay? Now, that wobble is going to cause the core to wobble. Now, the core is going to have ice and what I'd like to call a subcore and cold volcanism to it. Now, the cold volcanism is what I'd say is happening down in the core, the outer core. It's kind of hard to explain. On the outside atmosphere of Saturn, it's nothing but gases, all right? But they're light gases. You could actually put Saturn in water and it would float, okay? But on the inside, you have a core that's larger than Earth. And inside that, you have a subcore, which is molting, kind of like how our Earth has a molten core. And all this molting is going to have volcanism under this cold atmosphere. That's what I call cold volcanism. You have a subcore that's leaking out lava, magma, whatever, under this blanket of hydrogen. Now, you know how Earth has a wobble to it. Now, this rotation is so fast that, of course, it gives, like I said with the fidget spinner, it gives a wobble to this planet. Okay, now, while that's wobbling, you're going to have the apex. It's going to reach its apex, and it's going to tilt the other way. And it's going to keep doing this. And that is going to create a hexagonal shape at the top of the planet. And as it comes out of this, now this storm, I'll just say, you could fit 3 Earths inside it. It's huge. As it comes out, the gases move over the planet very, very fast, cooling and condensing. And once they get to the bottom, they condense so much that they get sucked into this vortex. Now, this vortex is roughly the size of the United States. So it's significantly smaller than the storm at the top, by probably 8 to 10 times smaller. Now, these rings are actually influencing the subcore to actually be molting because of the tidal friction. All right. Now, these moons are also going to contribute to the wobble and this hexagonal shape. So basically, we have cold volcanism going on, which is warmth on the inside of the planet. And when these gases condense as they get pulled in, they move through the middle of the planet around the core, and they warm up with all that cold volcanism going on. So when they warm up, they expand and come out the top in a hexagonal pattern. Once again, moving over the planet within 10 hours. I mean, it only takes 9.5, 10 hours for the planet to actually rotate. So that's extremely fast. These winds are, it's moving at 300 miles per hour, I believe, something around there. 300 to 600 miles per hour, something around there. It's very, very fast. So once they move over the planet, they're cooling and condensing.